All right, guys, so doing a quick video here on the intermediate value theorem, and I put in our notes how the book defines it, but I wanted to kind of do just a more basic definition that we can kind of think about it and use in class. So the intermediate value theorem really says that when you have 2 points on a curve and they put A and B in these pictures, so when you have 2 points on a curve, and there's one below a line, and I'm going to put line in quotes because it could be just a value really is what we're thinking of. So they picked like this f of b up here as one value, and then one above a value or a line. So really, f of b should have been my above. F of a would be the value that I chose below. Then we say there is at least 1 point on the curve that lies on a value between those lines. Usually we're talking about the x-axis, and this is to help finding zeros. And like I said before, the book really kind of defines it more with our x and y's here. So looking at this definition, it says is I really should specify before, the function has to be continuous. So if it's continuous over some interval of points, there's value such that between two y values, so f of a and f of b, there is some number where if we pick like a c value, so that's another y value in between, and they said in between a and b, then it'll be like on that line or on that point. So I tried to go and explain it a little more, I don't know, friendly definition up here going through to check that out. Okay, so the first practice here is really just a practice in finding the zeros on your calculator. So I'm going to put this one in my calculator, x squared minus 6 and x plus 4. So let me get back to my calculator. Bring it up for us. Very slowly. All right, so I'm going to graph. I'm going to clear out what I have over here. And then I'm putting in x squared minus 6. Make sure we have parentheses around a numerator and around our denominator. Okay, and we wanted to find the zeros between -3 and 4. So I'm actually going to go ahead and change my window to just, I'll give us a little space between -4 and 5. I don't think I'm going to need up to 500,000 like I have here. So I'll just go back to -10 and 10. We only need to see zeros. So that should be good. Perfect. So I can even just approximate these, right? I see that this is -1, -2, maybe -2.5, and then same thing over here. But to find the zeros on the calculator, we're going to go second. Our trace is the calculate menu. And number 2 is 0. So since there are 2 zeros on our screen, we need to specify which one we're looking for. So it says, give me a left boundary. What is the left bound of the first 0? So I'm going to look at this 0 right here. It's going to be what I'm looking for. So I'm going to move my little cursor to the left, or I could just type in a number. So I'm to the left of the 0. I hit enter. Now it wants a right boundary. So I'll just type it in this time. -2 is to the right of that 0. and hit enter. So if my 0 is between these boundary lines, then I hit enter for my guess. Otherwise, if there's more than one, you could like move it closer and take a guess, but I'm just gonna hit enter, and there we go, negative 2.44949. So that's my first 0. So now I'm gonna do the same thing for the second. Maybe you guys should try it out and then make sure it matches up. Second, calculate 0. A left bound, I want this guy over here now, so I'll say like 1. And I'll make my right bound 3. And guess. And there we go. It's just positive 2.4494897, right? So really close. So that's how we find our zeros on a calculator. Okay, last thing to wrap up quickly is if we're given like a set of function values, and really this is the intermediate value theorem at work. So if I was given these x's and y's, I really should have had the question up here, but it's this one that we're going with. Determine between which consecutive integers the real zeros are located. So whenever the sign changes, that's when we're going to have a 0. So from negative 13 to 2, we would have a 0 between these values, right? Because I need to cross over the x-axis if this is a continuous function. And they really should probably add that this is a continuous function, right? There's no breaks but going through. So any sign change looks like we would have another 0 between 2 and negative 1, and then one more again between negative 1 and 2. And if we graphed, right, these points, then that would make it super clear probably. So if I had a point at 0, 2, and then I had a point at 1, negative 1, and 2, 2, right? If it's continuous, I have to go through the x-axis. So that's our intermediate value theorem, and hopefully that makes sense.